Hello, welcome back to Flip. So today we are on paper chromatography. Paper chromatography really is just to separate samples into its components. So remember we talked about how to separate liquid mixture, liquid solid mixture, solid mixture. Okay, those kind. But this one really is just from one sample itself, one liquid sample, if you will. Then we separate them into their many components. Okay. Basically, the idea behind this is that different components in sample have different solubility in solvent. Okay, so for example, okay, in the case of maybe say a black dye, okay, you can't see a black dye here, so I'll just draw it white. Okay, so this black dye, okay, is made up of, for example, a pink dye with red dye with blue dye, for example. Okay, of course there's a lot more to it, but we just use 3 colors in this case. Okay, so this black dye in water, okay, for example, in water, okay, it will break up into 3 components. Okay, for example, the pink one, okay, has maybe say it's 100, okay, say 90%. Okay, it's able to dissolve 90% in water. That means dissolve very well. The red one, for example, is just maybe say 75%. Blue one, of course, maybe you just put it at maybe say 15%. Okay, so based on this number, which is not this is just a rough gauge, pink one is able to be dissolved, okay, soluble in a solvent much better than the rest of them. Okay, and this will impact on how they look in the paper chromatography later. Okay, I'll explain to you later, okay, using these 3 colors. Okay, you'll see what it means. Just keep in mind that pink is better, is more soluble in water than red, which is in turn more soluble than blue. Okay, so the idea is that when solvent is pulled up from the filter paper via capillary reaction, components made to travel different distance. Okay, we will draw it out later and you will see what it means here. Maybe I'll just explain what's a capillary reaction. Capillary reaction is really just a movement, okay, of water against gravity. Okay, so this one is a bit counterintuitive because how can a water just go against gravity, right? But because the tube they are traveling is so small, okay, that it's able to move up. Okay, this one you don't have to know in detail. Just know that it's capillary reaction. So this is the procedure. Okay, I thought we can draw it together. Okay, so in this case, draw a line on a strip of filter paper using a pencil and ruler. Okay, so maybe I'll just draw it like this. Okay, make sure it's straight line. Okay, maybe I'll use white color to draw. Make sure it's straight. Okay, then you place a drop of dye on the line using a dropper. Okay, I'll put black dye, but of course you cannot see black, so I'll just use white to substitute. Okay, so this is my black dye. I'll drop it in the middle. Okay, then you place a drop of, next one is you place some water in the beaker. Okay, so what I do here is I have a beaker here. Okay, and this is my water. Okay, then you suspend this filter paper on supporting rods such that the end of filter paper barely touches the water surface. What does this mean? It's really just like this. Okay, so imagine now this is my beaker again. Okay, not drawn to scale. Okay, this is not so big. Okay, it's actually quite small. It's just like this. Okay, so you can see that it just barely touches the water, not the whole thing. Okay, and this one is where the drop lies. So you can see that the drop does not touch the water surface at the beginning. Okay, after that, then it will do up. It will touch it. And you drag the components up. Okay, then allow the setup to stand. Okay, so that's all. The rest you just leave it to capillary reaction, which will do it for you. Okay, let's see what happens after this. Okay, the result is that, okay, the solvent will travel up the filter paper and brings the color of the drop of dye with it, and the dye will spread into different colors that make up the dye. So remember I told you that in this special dye of ours, okay, this black dye is only made up of, okay, can I draw? Yeah, you can see it here. Okay, I'll just rewrite it here so you can see. Pink is 90%. That means it's good. It's very soluble in the water. Red is 75. Blue is only 15%, for example. Okay, so you can see how well they bind to the water. So now my water, when it touches the surface here, okay, it will be pulled up by capillary reaction. And what happens now is that my dye will slowly break up into 3 components. Okay, as you can see, it moves up here. When it moves up, okay, which one is the least soluble in water? Okay, it's the blue one, right? So blue one will actually cannot travel very far. It will just be lag behind as the water continue going, while these two will stay in the water because it's very soluble. But once it reaches another point, for example here, the red one starts to drop out as well because it can no longer keep up with the water. Okay, because it's only that soluble in water only, 75. Whereas the pink one can continue all the way. Okay, hopefully it makes sense, okay? So you can see that really the solubility determines how far the droplet goes. Okay, so these 3 things, they are not new droplets. These 3 things made up this black or white droplet here, which breaks up into these 3. And based on how soluble they are in water, the solvent, they will travel to different distance. Okay, and that is what we mean here. Solvent travels up the filter paper and brings the drop of dye with it. Okay, this is the white drop of dye that we talked about. And it spreads out into different colors, okay, which is, in this case, blue, red, and pink. Okay, that make up the dye, which is the white one. Okay, so final recap. This one breaks up into 3 different dyes, which travels to 3 different distance based on how soluble they are in water, which is the solvent in this case. Okay, so that's the end for chromatography procedure. Next, we'll move on to the analysis of this chromatography.